How is safety analyzed in aircraft systems? In automotive, you might think of HARA, but in aerospace, a different approach is used. Safety is analyzed through structured assessment methods. This is defined in ARP4761A. It includes techniques such as functional hazard assessment, fault tree analysis, and failure mode and effects analysis. In this video, we explain what ARP4761A is, how these methods work, and how they fit into system development. Why does ARP4761A matter? In aircraft systems, failures can have severe consequences. This makes safety a central concern. Hazards must be identified and analyzed at system level. This cannot be done informally. It requires a structured approach. Safety assessment must be performed early and continuously throughout development. The results directly influence system design decisions, and they are essential for certification. ARP4761A provides the methods to perform this analysis in a consistent and systematic way. So what is ARP4761A? ARP4761A is a guideline for safety assessment in aerospace. It defines how hazards are identified, analyzed, and managed. The standard includes a set of structured methods. These include functional hazard assessment, fault tree analysis, and failure mode and effects analysis. These methods are applied across the system lifecycle. They support both design decisions and certification activities. So ARP4761A provides a consistent framework for analyzing safety in aircraft systems. So how does the safety assessment process work? It starts with a functional hazard assessment. Here, potential hazards are identified based on system functions. Next comes the preliminary system safety assessment. This step analyzes how these hazards can be mitigated in the system design. Then follows the system safety assessment. This is a more detailed analysis based on the implemented system. Finally, the results are validated, but this is not a linear process. Safety assessment is iterative. New findings can lead to updates in earlier stages. ARP4761A includes several key methods. Each method focuses on a different level of analysis. FHA is performed at the functional level. It identifies potential hazards based on system functions. FTA focuses on system-level failures. It analyzes how different causes can lead to a critical event. FMEA looks at individual components. It identifies possible failure modes and their effects. These methods are not used in isolation. They complement each other and provide different perspectives on system safety. So how does ARP4761A relate to ARP4754B? ARP4754B defines how the system is developed. ARP4761A provides the safety assessment methods. These two are closely connected. System development provides information about functions and architecture. This information is used in safety analysis. In return, the results of the safety assessment influence system design. They define safety requirements and constraints. So there is a continuous interaction between development and safety. So how does ARP4761A compare to HARA? Both approaches analyze safety risks at system level, but they differ in how this is done. ARP4761A uses multiple methods, such as FHA, FTA, and FMEA. HARA, on the other hand, follows a more structured approach. It evaluates risk based on severity, exposure, and controllability. The outputs are also different. HARA defines ASIL levels and safety goals. ARP4761A provides detailed safety analyses and requirements, but both share the same objective: ensuring safe system behavior. What challenges arise in practice? One of the biggest challenges is identifying all relevant hazards. Aircraft systems are highly complex, with many interacting elements. Another challenge is combining different analysis methods. Each method provides a different perspective. Ensuring consistency across these analyses is not trivial. Completeness is also critical. Missing a hazard can have serious consequences. And finally, there is alignment with certification expectations. All results must be clearly justified and documented. There are several common misunderstandings about ARP4761A. One of the most common is that it is just a single method. In reality, it includes multiple analysis techniques. Another misconception is that safety assessment is a one-time activity, but it is an iterative process throughout development. Some also believe that only qualitative analysis is required, but both qualitative and quantitative methods are used. And finally, it is often seen as separate from system development. In reality, it is tightly integrated into the development process. Let's summarize the key points. ARP4761A defines how safety is analyzed in aerospace systems. It uses multiple methods, such as FHA, FTA, and FMEA. These methods are applied across the system lifecycle. Safety assessment is closely integrated with system development. All of this ensures that hazards are identified and risks are properly managed. And ultimately, ARP4761A is essential for safe aircraft systems. If you want to go beyond this introduction to ARP4761A, we offer a wide range of online training programs on our website. In aerospace, we cover system development, software standards like D0178C, and safety assessment based on ARP4761A. In automotive, we provide training on functional safety, SOTIF, cybersecurity, and development processes such as ASPICE. We also cover medical devices, where safety-critical development and regulatory requirements play a key role. All courses are designed to be practical and applicable in real engineering projects. You can find the link in the video description and in the pinned comment below. If you found this video helpful, feel free to give it a like and subscribe to the channel. We regularly publish content on functional safety, cybersecurity, and aerospace standards. Thank you for watching, and we look forward to seeing you in the next video.